Oh yeah, so we're at the point where we have collected so many XP points towards our understanding of quadratics, and we're going to continue to do that in this practice by graphing more parabolas. And part of the reason for that is because it's so important. I feel like half of this series has been graphing parabolas or quadratics, and the other half has been solving quadratics, which is the gist of quadratic equations. It's either graphing them or solving them, and in a lot of cases, combining the two to make these cool pictures we have been making. And part of the reason why we graph quadratics is because a lot of us, like me, I prefer to see a visual of something that I'm solving for rather than just solving it abstractly, blindly, without looking at it. So graphing quadratics is something that is not very easy at the beginning, but once you're able to master it, you prefer to do it because it shows you a picture of what it is you're actually trying to interpret or solve. And that's why a lot of my students that say I don't like graphing, they don't get the picture. So let's get started. All right. So another thing that I wanted to mention that is a prerequisite to understanding these concepts is all of the 20 something ideas that we've been talking about before. But the other one that's not involved in the quadratics part of the series is function notation. That's something that hopefully I expect you to have at least some sort of experience with it in the past, or at least you have seen it somewhere. And now let's talk about it a little bit because it is important for what we're going to be doing in the next few videos. All right. I will be using that notation a lot. All right. So don't worry about the word function. All it means is in the past we have seen y equals negative x times x, the something is x minus 8. All right, but all it is now instead of writing our y in this format, we're going to write it in a fancy notation known as function. I don't like to say that, so I'm going to rephrase that. Now we're going to rewrite our y as a fancy way of saying y equals. All right, this is our fancy way of saying y equals. It's not f times x, it's f of x. F of x. All right, so here we go. I want you to think of this as f of x. Instead of f of x, just think y value equals negative x times something. The something is x minus 8. So when you see this, I don't want you to think of it as f times 0. Let's think of it as the y value when x is 0. Notice that x is the thing inside the parentheses. This one means the y value when x is 1. See if you catch the pattern. Try to join in with me the next two. This one means the y value when x is 2. So don't think f, think y value when x is 4. And similar to this equation here on 1b, uh, sometimes it could be f of x or g of x or k of x or whatever other letter instead of f. Like in this case, we're going to use h. And instead of x, sometimes we're going to use t because what we're moving forward to is word problems. And a lot of times t will involve the variable that stands for time. And sometimes h will stand for something like height. So just to give you a preview where we're going. But still, even though we see that, we still think the y value in terms of time or in terms of t. So this would mean the y value when t is 0 or the height when time is 0. Therefore, what do you think this one means? The y value when t is 2, or in other words, the height when t is 2, all right? So when we think about that, it's just algebra or plugging in simple x values and evaluating y. So this says, what's the y value when x is 0? Wherever we see an x, we're going to say, all right, this one's negative 0 times 0 minus 8. And what is that? Take some time to figure it out. I'm just going to write what all of these represent and then evaluate them. So this one means the y value when x is 1. So wherever we see x, we will replace that with negative 1 times 1 minus 8. The next one is negative 2 times 2 minus 8. Remember that I expect you to do this. I already know this or have some familiarity, so I'm just going to move faster. And this one is negative 4 times 4 minus 8. I already did the slowest part of the video that I could. So this would turn into 0 times whatever this is, it's still going to be a 0, so it doesn't matter. This one is going to be 1 minus 8 is negative 7 times negative 1 is 7. And then 2 minus 8 is negative 6 times negative 2 is 12. And then 4 minus 8 is negative 4 times 4 is 16. I hope that's correct. If I made a mistake on any of these, At least the concept was right. But that's not the idea for this video. It's just rather what it means, which I spent more of the time doing rather than explaining how I got 7 or 12 or 16. Does that change how we were thinking in this part? No, it doesn't. We're still going to plug in a, wherever we see a t, now we're going to substitute that with the 0. So -3 times 0 plus 2 times 0 minus 6. And then this one will become -3 times 2 plus 2 times 2 minus 6. And remember, all we did was substitute wherever we saw the 0. I'm sorry, wherever we saw this t, we substituted with the 0. So instead of this t, now it became a 0. Instead of this t, now it became a 0. And same idea here. I'll do a different color. Wherever we saw the t, now it is a 2. Wherever we saw a t on the original equation, now it is a 2. That's what it was going on. And let's evaluate this. You do it in your head as quickly as, I'm going to do it in my head as quickly as I can, but that gives you more time for you to check. So this one becomes 36, I believe. Yep. And again, if not, at least I know this is correct. So don't worry about this too much if I make mistakes. All right, and this one is, I think that one's 48. But I know this is correct, all right? So let's move on. I don't even want to waste time checking that. You guys check that and let me know in the comments that I make mistakes, but I did that as quickly as I could to save time for what's more important. So that's function notation. It will be used in the next few problems. So again, one of the questions that you may have had at this point, if you had never seen this before, is why are we graphing all these parabolas so much? And it just feels like repetition, even though it's cool and all, but what's the purpose behind it? Is because it applies to a lot of word problems, and I want to show you not the whole thing, but the idea behind it. So let's try and focus on, when we see this, we're still going to think y value, and instead of thinking x, now we see variables like t. So this is the t-axis, and I want you to think this is the height axis, because normally a lot of time t means seconds, and as I hinted before, h of t, meaning the y value in terms of time, is going to mean height in meters, right? And the unit for height is meters, the unit for time is seconds. And because this one, hopefully you identify vertex form, that's where we're going to start. And let's get started and see if we can graph some of these things. The vertex is going to be when the something square is equal to 0, that's when t equals 0. So the vertex is located as 0 comma something. When this whole thing is equal to 0, the y value is 36. Boom, we have a point quickly. And then it says letter B, identify the t and h intercepts. So letter B, we're going to solve for, last few problems, it was the x-intercepts. So we're going to solve for t-intercepts. What do you know about the t-intercepts? Is that the y value is 0 normally for x-intercepts, but now we're going to say h equals 0. Now the height equals 0. That's when we find the t-intercepts. And that would make more sense when we solve word problems coming up. I'm going to pause right here and give you time to synthesize what's going on. Before we would say x-intercepts, y equals 0. Now we're saying t-intercepts is h equals 0 because the t replaced the x variable and the y was replaced by the h variable. So let's go ahead and solve that. Here's our original equation right here. All right. So now we can say that 0 equals -9 t squared plus 36. If you want to be a smart mathematician and efficient, please don't subtract 36 to both sides. The most convenient thing to do is add 9t squared, since this is a 0 to both sides. So we can say 9t squared equals 36. And that tells us that this 9 represents a vertical stretch of 9, all right? So this parabola has been stretched vertically, and therefore we are going to divide both sides by 9. So it gives us t squared equals 4. And then we're going to say, all right, something squared equals 4. What are the two possibilities? Is t equals a positive or a -2? So we have to think in terms of coordinates 2, 0 and negative 2, 0. Negative 2, 0 and 2, 0. All right. So let's start plotting those points. We have negative 2, 0, positive 2, 0. And we knew a vertex of 0, negative 36. And if you notice, if you're paying close attention, not only is that a vertex, what other point does that represent? It's on the h-axis, or what used to be the y-axis. So it's also the h-axis. We don't need to solve for that anymore. So that's key. That one's powerful. This one is the vertex, but also the height intercept, right? And then you can see that perfect symmetry about the two sides of the h-axis. I was going to do something on purpose. Let's see if I remember this time. There we go. That's pretty much what we have so far here. And I'm going to do it on purpose. I don't want to do it twice. But I want you to think about, why am I purposely drawing the left side of the parabola in this format? Where on the right side I use a solid line, and here I use a dashed line. So I want you to think of this box right here. What do the units stand for? It's no longer x and y. It stands for seconds, meaning time, and height. So I want you to think, can time be positive, moving in the positive direction? Yes. Can time be 0? Yes. But can time be moving in the negative direction? No way. So anything left of t equals 0, it makes sense in terms of the graph, but it doesn't make sense in the context of this problem. So whatever we get here, we're going to ignore, which is why I was saying one of these two solutions will make, or this x-intercept we're going to consider, but the other one not really. This is 2, 0, but this one doesn't really make sense, even though I'm still going to use it to make my sketch. That one doesn't make sense in the context of the problem, but it's going to help us make our sketch, all right? So I want you to think that way. All right, cool. And the last thing we know is sketch the graph. We're done. Oh, and I wanted to point out, last thing I want you to think about. So we already answered that question, but look at what happens here. Now I drew like that on purpose. Why am I doing that on purpose? Where on the right side, there seems to be something going off, but at least this one's consistent. It's always dashed line. But why is there a dashed line here and a solid line here? Actually, there's no other things given to you, but this answer will be given to us in future videos. All right, but that's the main thing I want you to think about, and there it is. Let's move on to the next one before we waste more time. And it's going to be something similar. Height in terms of time, t equals seconds. Height is in meters. Here's our equation. All right, so let's check it out. Now it's not given to us in the same format as before. Now we have to do something different. This one was vertex form. What do you recognize this as? And this one's kind of difficult because we haven't done many examples like this. But if it helps, then we can think plus 0. I'm going to erase it, but there it is. That will help us a lot. It's got 3 terms. There's no GCF. So therefore, it is y-intercept form. So we need to try and factor this. Y-intercept is 0. We already know that. So let's start to show all our work here. Let's solve for the t-intercepts. T-intercepts means like when in the previous problems we were trying to solve for x. And that's when h equals 0. The other axis is equal to 0. So we can say that 0 equals negative t squared plus at. Let's factor out. There's no GCF other than a negative 1. So t squared minus at. All right, therefore, oh, my bad. T isn't common. So negative t. And I realized that because what was inside has still something in common. So negative t, and then it's going to be t minus 8. That's perfect. So that means that the t-intercepts are located when t equals 0 or when t equals 8. And those 2 points are 0, 0 because the height is 0 and a, 0. There it is. Those are 2 points that will help us tremendously in this process. We have 0, 0 and 8, 0. One thing we should identify, the original equation had negative something squared, so we should expect a parabola that curves downwards rather than upwards. And let's find vertex. That's what I would go next. Vertex would be at the midpoint of these two x-intercepts, and that's when t equals, actually we don't know. What's right in the middle of 0 and 8? That's not that difficult, actually. It is t equals 4. That's the midpoint of 0 and 8. So then that will occur when t equals 4. We have done things like this before. Let's plug it into the original equation. I prefer the factored form so that we get h of 4. Notice how we're using that format now. The y value when t, or the height when t equals 4 is going to be a negative 4. We're using this factored form now. And then times 4 minus 8. So that is a negative 4 times negative 4. So the height at 4 seconds is 16. And notice how we have this awesome looking parabola that is curving downwards. Oh, my bad. Pretend you didn't see that. There we go. We should expect a lot of symmetry on the right side. And again, I want you to think of why I'm doing this. If it doesn't make sense to you yet, that's fine. But it will in the next video because we will have more context to it. All right, I hope we can move a little bit faster. Oh, I didn't label this one. This is 4, 16. Cool. I think we have one more. And look, this is as advanced as this is going to get in terms of these, in my opinion. If you can do this one, then you're set for whatever application or word problem is coming our way. All right. So we have it in, think about it. Is this in vertex form? Is it in factored or standard form? It's standard form, y-intercept form. In this case, the h-intercept is the easiest one. H-intercept is when t equals 0. And that is 0, 36. Remember, when t equals 0, these two go to 0. And we got 1 point. Now the next two are the hardest part of the problem, but I think they're very crucial. It reveals the rest of the problem. So we know that the t-intercepts occur when h equals 0, or h of t equals 0. In other words, so we're going to get that 0 equals negative 3t squared plus 12t plus 36. We should be thinking at this point, we have to either identify a perfect square or either factor. And the nice thing is we could factor a GCF, but please tell me you weren't thinking just 3. Notice how there's a negative right there. So we're going to say negative 3 times something. Opposite of t squared is positive t squared. Opposite of positive 12 is negative 4t. And the opposite of positive is negative 12. You can always check by distributing this back to the original. If it doesn't match, then check your signs or something. So 0 equals negative 3 times something times something. We want to know a product and sum type of factoring idea. Two numbers that multiply to negative 12 but combine to negative 4. Some form of 6 and 2, it looks like. If we have negative 6 and positive 2. So that means that t equals 6. And the other option at t-intercept is negative 2. So we're going to write them as points 6, 0 and negative 2, 0. And I think we already have the t-intercept as 0, 36. Perfect. So look, we have 6, 0 here. Negative 2, 0 here. And we want to figure out what's in between them. What's right in the middle of 6 and negative 2? 6 minus 2 is 4, divided by 2. Line of symmetry somewhere here. At t equals 2. So we know this is going to look something like this. But let's figure out what that highest point is going to be. And we know it's the highest point due to the a term being a negative. So we're going to figure out vertex. That occurs when t equals 2. And we said that factoring is very powerful because it makes the calculations easier. So we're going to say the height when t equals 2. The y value when x is 2 is how we used to think about it. Let's plug it in right here. This is not t, so just keep it as negative 3. And then 2 minus 6. So 2 minus 6, and then times 2 plus 2. This should become negative 3 times negative 4 times 4. So the height at t equals 2 should be 48. All right. And our graph should look something like this. And again, I want you to think about why I'm purposefully doing this. On the left side of the equation, or the parabola, and check out the right side. Oh man, that one's harder for me. I'm just gonna keep like that because that was hard to make. But oh, one more thing we can label. I don't know if I did that for the previous ones. Nope, that's it. Okay, but we do know this point. It is 0.36, and we're not gonna get away with this. Look, there's 2 units to the right, to the left side of the line of symmetry, and 2 to the right. That should be this point, but whatever. Not drawn the perfect way. This should be 4,36. We should be able to label that based on symmetry. That's the matching point or the point of symmetry. All right, I think we got one more example that we can apply to word problems and applications of parabolas or quadratics. This is one of my favorite ones, by the way. Sometimes we're going to say A of W, and think about what types of math we use A for. It stands for area, and sometimes it's going to be for width. Area in terms of width. Area in terms of width. This is my favorite form of equations, by the way, so that's why I think this one's going to go faster. Hopefully you recognize this as. Give you 3 seconds to pause it or figure it out yourself. 1, 2, 3. It is factored form. So we can start with W-intercepts instead of T or X-intercepts. So W-intercepts are when the two somethings are equal to 0. And you can say something times something. So either W equals 0, W in. That's kind of weird because we haven't seen that yet. It's W equals 0. Or W, and that was when area equals 0. And what used to be y equals 0. Or W equals what? 10. But remember, those are coordinates, 0, 0, and 10, 0. Don't forget that. Let's plot those, 0, 0 here, 10, 0. And then we're going to say that we want to find the midpoint of that. What's right in between those two? It is 5. When W equals 5. So this is when W equals 5. We have our highest or lowest point. Now be careful. If you don't pay attention, you're going to think, oh, this is a parabola that curves downwards. But I want you to think, what's positive 2W times negative 2W? There's a negative 2W squared right there. So you should be thinking there's a parabola that curves downwards. Otherwise, you got tricked. And it should look something like this. And remember, I want you to think about why I do this after that point and why this occurs here. And it'll make more sense when we have more words, more context to these problems. And Let's just label that whatever point that is. It is 5 comma something. So we can go enjoy the rest of our days. Vertex on this particular problem is when W equals 5. So we're going to say that area when W equals 5 is 2 times 5 times 10 minus 5. We plug that into the factored form that was given to us. We didn't have to factor it. So then we say that this is 10 times 5, which means the area when W is 5, or the width is 5, is 50. So we have 5 comma 50. Notice how this point 5 comma 50 can be represented here too. 5 comma 50. And done. I hope to see you and myself applying these type of ideas in our future coming videos about work problems and applications of quadratics. Man, this is starting to get a lot of fun. I hope that you're hyped like me. And let's continue to explore and collect some more XP points based on everything we've done before and see how it's all connected. It's not just, oh, this is one lesson that's separated from the other one, and 17 has nothing to do with episode 3. No, at this point, we've been connecting everything very nicely. So go enjoy the rest of your day. Go get some good food. Go for a walk. Whatever makes you happy, go and do it right now, because I'm about to do that. About to go skate. All right, so enjoy the rest of your day. Bye.